moment here for the setup. Okay. All right. So welcome to our webinar series. Today, our topic is going to be best practices in teaching students to code, presented by our VP of Education, Mark Barnett.
Hey, everyone.
All right. So this is our agenda for today. I'll do a little bit of an introduction about BSD education. And Mark's going to take over. So he's going to talk a bit about himself, so you get to know him and his background. And then we're going to dive into the topic of pair programming, use, modify, create, model, and also the PRIM method. And we'll have time for questions at the end. So along the way, throughout the webinar, please feel free to leave your questions in the chat box, and we will come to them at the end of the session. So here's a little bit about BSD Education. We are an international organization of educators and technologists. We provide resources and partner with different schools and organizations to bring digital skills and digital learning curriculum into the classroom. Our main focus is to enable teachers and support teachers in that journey. We provide the curriculum, as I mentioned before, designed in-house through rigorous research. And then we also have our development team that has built our learning platform where the curriculum is hosted. On top of that, of course, we provide professional development that goes with it to support the teachers to bring digital skills learning into the classroom. So all of this combined, we're kind of a one-stop shop for teachers. We have you covered for any digital skills and technology learning that you want to bring into the classroom. And as for coding, we focus on text-based coding, which is HTML, CSS, and JavaScript. So Mark is going to tell us a little bit more in how we approach the teaching and learning in this. So over to you, Mark. I'm going to stop sharing screen.
And I will share my screen. All right, hey everyone, welcome to our webinar. See some familiar names on the list there, and if you're joining us live, also thank you for joining. My name is Mark, and I'm the Vice President of Education, and along with my team, we develop all of the curriculum for BSD, of which we have over 600 hours and counting of curriculum for students from grade 3 all the way through high school. So it's my role at BSD to make sure that all of the curriculum that we write aligns to sound pedagogical approaches, which means that we do research and investigate what are the best practices for learning how to code, and we embed that into our curriculum, of which we plan to share a little bit today. I'm also a PhD student at Chiang Mai University in Northern Thailand, which is where I'm coming to you from today. And I'm studying computer science, education, artificial intelligence, and how children relate to that. And I have a lifelong history of being an educator and working in the field of education, specifically around digital skills, coding, robotics, 3D printing, makerspace, all that kind of stuff. So we want to invite you to join. We have a couple of questions. And so we use this interactive feature called WooClap. So Eva, if you could put that link into the chat for everyone to see, but you can also use your mobile phone right now and open up the camera, and you can scan the QR code, which will take you directly to the question, or you can just click on the link in the chat and you can join. We will have another question later on in the webinar, so you may want to just keep that open or keep it handy in another tab or on your phone. But I'll leave it up just for a second for everyone to gather that. If you haven't seen it, it's also in the chat. But once you are logged in, you can see the next question. So I'm going to go ahead and move on to the question, and we will start to see some of the live results. So the question is, what keeps most people from learning to code? And I've got 3 answer choices here. 1, lack of experience. 2, lack of time. 3, fear of learning. So, you can reflect back on your own experience about coding, or maybe you're about to embark on a learning journey for learning how to code. And how does that make you feel? And what's holding you back from that experience so far? It looks like the majority of our respondents so far are saying, it's 100% so far, that the fear of learning to code is what's keeping most people back, which is actually backed by research. So, and this is not just in the realm of education for teachers, but it's in the realm of adults who even are considering entering the space to work in digital technologies and work in coding, is that it's daunting. And so because of that fear of not understanding it and not knowing what it's about, it holds people back and it keeps people from moving forward. So a lot of research has gone into how can we overcome that fear and how can we provide opportunities for students to move past that fear. So today, the purpose of the webinar is to share with you some research-based methods that help alleviate the fear of learning, and we'll also give you some tips and tools that you can use in the classroom. So it looks like everyone agrees that the fear of learning is quite high with code. They say that the thing that people fear the most is public speaking. Perhaps learning to code might be right underneath that. Eva, what do you think? Do you agree that is fear or lack of time or lack of experience? Which one for you?
I think it's definitely a combination of lack of time and fear of learning. Yeah. Sometimes I still get like, am I going to break this? Am I going to break the computer? Even though I work with technology every day.
Yeah, and Eva's come a long way, I think. From for her first role at BSD, having very little knowledge of coding, now leads high school students in computer science and programming. So well done, Eva.
Thanks.
All right, so the first method that I want to talk about is called pair programming. And as the name suggests, it's 2 students working together in order to accomplish a task, a mission, or a goal, or an objective. And the way that it works is you kind of have these 2 roles. One person is the driver, or the coder, the programmer, the one who's doing the work, and the other person is the navigator. The navigator is the person who is checking for understanding, asking questions, double checking on things. And this method actually came from industry. So, real programmers, who work in this as a profession, use this method. And typically the way it works is that you would have one computer. And this is also helpful in education settings where access to computing may be difficult. So we can, pair students up on one computer. But besides that, it has a pedagogical value that 2 brains are better than 1, kind of. So when students are communicating and collaborating and discussing and problem solving, then they're able to both learn from that experience. So whenever you want to try pair programming for the first time, you will want to explain the role very carefully, and you'll want to kind of model the experience for students. And the way that I do it is I set up a timer in the room, and I let students use the roles for about 10 minutes, and then the timer goes off, and then they have to switch the role, all right? Now, just because the timer goes off doesn't always mean that that's really the best time to switch. But what it does is it starts to put into the students' minds that there is a reason for us to switch and we need to change the roles. So at first, when introducing pair programming, I have it set on a timer. After a while, when students get the hang of it and understand the reason for switching back and forth, I allow them to switch back and forth naturally based on what they're currently doing. Now, what I will do sometimes is just go back and check in and be like, Roger, I see that you've been the driver for at least 30 minutes. Is Alicia okay with that? You know, kind of like you just want to check in and ask some probing questions to make sure that they are taking turns. But it's a really valuable way to get students communicating and collaborating. This can even be done virtually, where students are working together, like they're kind of like we're doing now. You're on Zoom or on Hangouts or something, and one student is sharing the screen, the other student is watching or doing the coding. So I think it's a really useful and valuable method. But the research about why this is a valuable thing goes back to the cognitive load theory. And if you want to learn more about the research behind this tool and what makes it useful and valuable, I'm going to ask Eva to place a link into the chat, which shows some research-based information. For those of you that want to go and read further and look at the documentation and read the research studies, you can. But the results of the research studies have shown that when students are using this method, they have a shared cognitive load. And because learning how to code demands a high cognitive ability, we have to really think and we have to solve problems. It really puts forth that idea that two heads are better than one. And so students are working together to solve problems. But one thing to note about the pair programming method is that it does require effective communication. Just because you put two kids down together next to each other and expect them to work together doesn't mean it's going to happen. So there needs to be some additional cues and some additional social emotional modeling for how to effectively communicate in these roles and how to ask questions. And so whenever I teach pair programming to my students, I usually model in front of the class, and I'll usually grab a student and ask them to join me, and then I would model and show examples of questions to ask, or I might put us in a situation that's difficult and we have to figure out how to solve that problem together. But this image kind of elaborates more on the roles. The driver is the one who operates the computer and is listening and taking advice from the navigator. The navigator is kind of looking at the overall objective and trying to look for errors, to problem solve, and to also maybe, like, if there's instructions or if there's a tutorial or if there's some other learning materials or information, the navigator would be interpreting that and then relaying that information to the driver. So it's a very powerful method, but it requires a bit of finesse, and it requires time and practice. So don't expect pair programming to be this magical way to solve all your problems. It's just a tool that you can use to help increase efficiency and also to lower that threshold of fear that I mentioned earlier, because when two people are working together, it's a little bit less daunting. It's kind of like, are you going to go up the mountain and face the dragon by yourself, or are you going to bring your best friend with you? So it's always good to have a friend or someone you can rely on. So here are my tips for pair programming. Model the activity first, which means you as the teacher can show what it's like. I also don't have students stay in the same partner group. Maybe they stay in the same partner group for the period of a project. Once that project is complete, then I will have them switch partners, because that gives them more experience with communication and effective communication. Because you might get really good at having one partner that you've gotten used to and you communicate well with. Now you've got to learn how to do that same thing with someone else. And so that helps also to build resilience and other critical skills that we might need as an adult. So one way that I help to have students use critical dialogue when they're doing pair programming is a formula for how they are to give each other feedback. And so this formula is called critical friends. And the way that you give critical friends feedback is you say, I like ... but I wonder ... So instead of saying, why did you just put that line of code there? It doesn't make any sense. That's stupid. It's rubbish. That might be what you're feeling inside. It might be what you want to say, but I ask my students to first pause and reflect and think about how can I formulate that in a way that is conducive to communication. So you might say, I like that you've progressed in the coding, but I wonder if you've thought about how that will affect the outputs or the variable, or whatever. So we're using this kind of dialogue to help and become friendly, but we can still give and receive criticism. So it's all about that effective communication. So I highly recommend you trying out pair programming. Of the strategies that I'm sharing today, it's the easiest to implement. Eva, have you had any experience with pair programming?
Yeah, I have used this with younger students I think it was grade 5 or 6. Yeah, and it was really effective. At first, it was really messy. I have to admit that. And, there's a lot of finger pointing. Why'd you do that? Or like, let me take the mouse. I can do it better than the keyboard. So the setup that Mark was talking about is really important in setting the scene for the students and how they can collaborate. And I think beyond the programming, this is a really great way for the students to practice some of the soft skills that are really critical in their learning today.
Yeah. I think that everyone will have a little bit of that experience of like, let me have the mouse. But I think it's natural and it's part of the learning experience as well. Mm-hmm. All right, I'm going to share 2 more strategies. The first one is called use, modify, create, and the second one is called prim. And now I've recommended here that we use the use, modify, and create for primary and prim for secondary, but that's really just a suggestion because I've definitely seen prim being used at the lower levels, and I've seen use, modify, create being shared everywhere. So I'm just offering this to you as a suggestion for a place to start. You as the educator will feel into it and decide for yourself which you want to implement at which grade range. So keep that in mind. So use, modify, and create. I like these methods that describe clearly what they are in the name. Use the code, change something about the code, then create with the code. So in order to first overcome that obstacle of fear of coding, it's easy to just use the code. So if you're just going to play a video game, then all you would do in the first step of use would be to play the video game. Then modify is very simple. We're not actually having to write code from scratch, but we're just changing or editing some of the code. Then once we have some experience with that and we feel a little bit more confident and comfortable, then we can start to create with code and apply it in a different context by taking what we've learned in the use and modify stages and then using that to create something. So I'd like to demonstrate this with an example from the BSD curriculum. And I'll show you some examples. But Eva, if you could share out the research background for this method. So this method is not something that I've created or that we've created at BSD, but it's something that's been researched and shared. And what I like about this method is that it helps students move from the agency of having little agency to having lots of agency. And what that means is at first the code is not mine. It's not, I'm just using it, I'm borrowing it, I'm looking at it. And then over time, through iterations, it does become mine because I understand what the code does and I can achieve something with it, or I can solve a problem with it. So I'm going to share another screen here. So I'm going to walk through the way that we would deliver this with BSD. So in the use stage, first we would do is play this game. So if students were taking a part in our video game design curriculum, the first thing that we would have them do is to actually play one of our games. So let me find the right tab. All right, so this is a video game that we've made, and we teach students how to build this video game, probably around the middle school range, the 5th to 6th grade and up. So the way this works is just called Space Jumper, and if you've ever seen one of these kind of games, you just well, I'm not very good at it, but you can try to jump on these platforms, and the character's goal is to get as high as possible, and then there's these little power-ups along the way. So yeah, I keep dying. So we would give students, time to experiment around and play with that. And, you kind of have to set a timer or they'll just keep playing on and on and on. But the next step would be that we would want students to actually edit or modify something. So we want to change something about the code itself. So what I'm going to do is here in the JavaScript on this line here, we can change the scale of the character. So if we go back and look, you can see the size of the character, the little spaceman here. It's set to a pretty small value. So I'm just going to modify that and change it from 0.1 to 0.3. I'm going to reload the code and see if that has any effect on the game. Is it easier to play now that the character is much bigger? Well, I seem to be doing that a little bit better. So this is the modify section of this method. And what you do here is you kind of iterate and you make changes, small changes, and see what the effect is. And then, kind of decide if that's something that's good or bad and continue to edit. So maybe 0.3 was too big. It was 0.1 earlier. Let's try 0.2. Whoops. And then I'm going to run the code here. So it's maybe just a tiny bit smaller. So what the goal here would be is for students to continue with their curiosity and try to find the optimal size of the character. And they could even change other parts of the code, like the speed at which the character moves or the spacing of the items. And look at me, I'm not doing too bad. All right, see, that's much better. So I think, what I would do for me is I would keep the value of this at 0.2. Look, I'm gonna get to 100 points here. Look at that. All right, good. So then the next step would be we would want students to take what they've learned and then to actually create something with it. So I'm just giving a demo here in the webinar, but in actuality, students would spend a lot more time in this stage. So at BSD, we have guided projects that lead students through building this so that they learn every step of the way through the JavaScript, the HTML, and the CSS, how to actually build this game. So they would spend a lot more time in this phase. But once they have that knowledge and they know how to build this type of game, then we would have them move into the create phase. So let me show you an example of what students could do after they've learned how to build the basic one. So here is a similar style of game. This one is another jumper. And so you just kind of click to jump and you try to avoid the rocks and then I died. But kind of using some of the same mechanics and using some of the same code, students are able to take what they've learned and make basically a new version of that. So if I go back to this, you can see, in the beginning, the students are just playing the game. Then they modify a little bit. We're changing the character size and the character height, et cetera. Then once they've learned how all that works, then they can, through a series of iterations, start to create something that does belong to them. So we're increasing agency and providing opportunities for students to make something that's useful. So this method, the use, modify, create, I think it's pretty simple. I think it's easy to implement, but one thing that we want to be cautious of is not to oversimplify it. Like I said, in the modify stage is where we're actually going to spend the most amount of time actually teaching students and preparing them for what they need so that they can create something. I like how in the slides here, Eva, I put create, build something. I should have put build something different to complete that. Eva, what do you think about the use, modify, create method?
I think it applies in so many different subject areas too, and even for students in their hobbies maybe. I'm just thinking back to when I was younger. I was trying to draw anime characters, but I'm no good at drawing. So I end up tracing first, and then gradually, well, the use part would be watching animes or like reading comics, and then I'll want to draw it, so I'll trace it, and then eventually I'll be able to draw it because I'm getting used to the shape and I understand the form of the character. So I think it it resonates in a lot of different areas for student learning and applies really well for coding.
Yeah, that's a good point that it has value in other subject areas as well. Yeah, cool. All right, the next method is the PRIM method. And a lot of research has gone into the PRIM method. And anytime a method has an acronym, you know that it's already been heavily researched and written about. So, once again, we're just sharing these research-based methods for your use. But PRIM stands for predict, run, investigate, modify, and make. So you can see it's a little bit, it has a few more steps than use, modify, create, which is why I recommended that use, modify, create would be for primary, and then PRIM would be for secondary. But like I mentioned before, you as the educator would need to make that call and use whichever you feel is most comfortable for yourself. So in the previous example, I used examples from BSD curriculum. If you don't have access to BSD curriculum, that's okay. You can still use these methods. So what I'm going to do is share with you a free resource to cover the PRIM method. So in case you're not a BSD customer or don't have access to BSD, you can still try these coding experiences out. So we're going to be using a Python editor called Trinket. Trinket is a free online platform to edit Python code or create with Python code, and you can install your own libraries. It's free for you, free for students. It saves your work online, so it's a very handy and useful tool. So the PRIM method, to expand a little bit more about how agency is converted, similar to the previous method, it starts off with, this is not mine. This is I'm just trying it out. So predicting, running, and investigating are the first three steps. Then modifying, changing means that it's partially mine. And then finally, when I make something new with all of the combined knowledge that I've had before, then it becomes all mine. So we're increasing agency over time. There are just more steps along the way in the PRIM method than there is with the use, modify, create. All right, so we're going to do a little experiment with Eva, and Eva is going to be my student. And we're going to run through the PRIM method together. And we're going to be specifically looking at this Python code. So this is a screenshot of Trinket, and we'll share the links to these later. But first, I wanted everyone to, if you've never coded in Python before, or you've never coded anything at all before, that's okay. What you can do is you can look at this code, and I want you to go line by line, read top to bottom, and see if you can discern what's going on here. What's happening with this code? Can you figure out anything? You may not be able to understand all of it, but surely you can digest and come up with some idea of what's happening on the screen. So Eva, I'm gonna let you decipher this code. Tell me what you think's happening here, what's going on, and what would be the output of this code?
Okay, so reading from top to bottom, I think there will be there's going to be a red turtle shape.
Okay. Yeah. Yep.
And then the pen up and pen down is throwing me off a little bit, but I think the pen up means that's where I want the pen to go.
Okay.
So maybe the minus 160 and 100 is the axis, and then the pen down is when it starts drawing.
Okay.
So I'm gonna put my pen down, and then the forward is the 200 is probably moving the distance of pixels, 200 pixels forward one way, and then I want it to turn right 90 degrees or 90 pixels.
Okay.
And then that repeats itself. Yeah, keeps going forward, 290, and then not sure what line 15 is.
Okay.
And then, yeah, and then it repeats again. So maybe it draws some sort of shape.
Okay.
Yeah.
Good. That was a good analysis and breakdown of what's going on. And for those of you out there who haven't done any coding before, this is new to you, or maybe you've done Scratch, but you haven't done Python or other text-based. It might look like a bunch of gibberish. But this is how we would decipher code. This is how any coder, whether they're brand new to coding or they're very experienced, is you just go line by line, top to bottom, and you try to discern and decipher what's going on here. So if you are familiar with Python, you'll recognize that we're using the Turtle library. So Turtle is just a Python library that gives you a visual element on the screen of which you can manipulate. So Turtle is used to make art, geometric shapes, and also it's a great learning tool for novices for Python. So I highly recommend, if you're learning or if you're a teacher using Python, to start off with Turtle. The Trinket website has a really cool Turtle tutorial series of lessons that walks you through how to manipulate the Turtle and how to start to do functions and loops and graphics with the Turtle. All right, so let's take a look and see what this code actually does.
Yay!
So yeah, Eva, as you predicted, there's a red turtle, and it makes some kind of a shape here. All right. So in the prim method, the first thing we just did was we predicted what's going to happen. We looked at the code. We decided this is what's going to happen. We made a prediction. Then we tested the prediction by running the code. And so we run the code and we see what the effect is and we see what the output is. Eva, what was right and what was wrong about your prediction?
I got the red turtle correct.
Mm-hmm.
I think I got line 7 and 7 to 9 also correct.
Mm-hmm.
Only line 15 onwards. Yeah, I think it helps complete the shape. That part I didn't get so right, but I think the distance was also like 200 pixels for forward, and then I'm not sure if I got the right for 90 pixels or degrees correct.
Yeah. Okay. Yeah. No, it was a good analysis. So in a previous webinar, we talked about other methods to help you switch from block-based coding to text-based coding. And one of the things that we shared was explaining the code. Explaining the code is very helpful because it gives you an idea of what you know and what you don't know. So I'm going to explain the code real quick, and we'll talk about where Eva was right. So first line of code, it says to import Turtle. That brings the Turtle library into the platform so we can work with it. First, I'm going to declare the name of the Turtle, and I called the name Seymour. Bonus points for anyone who knows why. I've declared that Seymour is going to be red, and in the Turtle library, the shape of the item, the Turtle can be different shapes. So we've gone with the traditional Turtle. It could be a square, a circle, a triangle, other things. The Turtle draws everywhere that it goes. So there's a pin feature, so that when the pin is up, the Turtle is not drawing. When the pin is down, it is drawing. So when the game first starts loading, or the program starts to load, the Turtle is typically going to be in the dead center of the screen. So if we can imagine an X and Y graph, that would be 0, 0. But what we want to do is start from a different location. So we will have student go to, and this is one of the things I love about Python, is that it uses the English language as part of the syntax, so it's a little bit easier to understand, to minus 160, 100, which is an X and Y value of here. Then we put the pin down so that all of the other tasks going forward, when the Turtle moves, it will leave behind that path. So then you're right, Eva, 200 is the pixel value. So we're moving forward by 200 pixels. However, when we turn right, the value here for 90 isn't a pixel value, but a degree value. So this is where it takes a little bit of learning to kind of figure these things out. What do the different values mean for the different functions? So we turn right, that puts us right here. Line 13, we're going to move forward again, which would bring us all the way down to here. And we'll turn right again, which makes us face this direction. Now what we see here at line 15 is actually a loop. It's called a for loop. And we have defined the range of this loop to be 2. So int stands for integer, and 2 is an integer. So this will repeat 2 times. So it's going to move forward by 200 pixels and turn right and repeat that twice. So from here, we'll drive forward, we'll turn right. That's the first instance of that loop. Then we'll do it again. we'll drive forward, and then we'll turn right and we'll end up exactly where we left off here. All right. So Eva, I think you got like 95% of the code right. So good job. And by the way, Eva does not program in Python yet.
Yet.
Awesome. So that we've kind of just come to the first two parts of the PREM method. So the next part of the PREM method is investigate. So we're going to use the same code. And what I want to do now is, kind of challenge our thinking a little bit about the code and what are some things we can do to learn more about the code. So Eva, the question I want to ask you is, how could we simplify this code so that the turtle creates a square with less number of steps? So from line 11 to line 17, how could we simplify that code so that we get the same result?
I think now knowing that line 15 to 17 is a loop, line 11 to 14 looks a bit redundant, like we don't have to type that twice. So maybe we can change the integer to 4 and then remove line 1 to 14 to make the full square.
Yeah, I think that would be definitely one way to do that. So in the investigate part of the PREM method, this is where you would let students conduct those investigations and experiments. And so you would ask questions like that, then tell the student, okay, go try that out. And now we're doing the live webinar, so I'm just giving you a simulation and an idea of what the PREM method looks like. But if this was a real classroom, I would tell Eva, okay, go try that out, and then report back to me what your findings were. And then I might ask some other questions like, what could we have the turtle repeat the square at a different location on the screen? Or what if we reverse the square? What if we started at the bottom right-hand corner and then went the other opposite direction? How would you modify and change the code for that? So it's through this investigation that you start to learn how the code works by tinkering around with it. So the next step would be for us to modify the code. And so the investigation leads directly into the modification of the code. So I might give a directive like, can you make a small green square with the similar code? All right, so we have to change a few things. We have to change the color to green. And since the other square there was 200 pixels wide, so now it's changed to 20 pixels wide. All right, so I would give students a series of objectives where they would have to modify the code. And along the way, then they would then learn what each of those functions does and what happens when I change the value of the different functions. Finally, we would want students to take what they've learned and to make something completely new with it. So here's an example of a student work where they took the same idea. So we're still importing the turtle. We've turned it to blue. Instead of the turtle shape, it's now the triangle shape. And instead of making a square, the student has used what they've learned to make a triangle shape. So it has only 3 turns. And so students had to figure out what was the correct degree for us to be able to put that into a loop so that it created the full triangle. And so this can be a fun experiment for students to figure out what is the right degree angle. And you can even bring in mathematics and how to calculate the angle of an object to further reinforce mathematical concepts. So Eva, do you think that knowing what you know so far about Python and Turtle, could you use it to make another shape?
Yes, I might try after this webinar. It looks fun.
Okay. If you could, Eva, drop into the chat, I've got 2 links to Trinket. And so I put a link to the code for this one. So anyone can take a look at that, experiment with it. You can even run your own investigations on that using the PREM method. And then I also put a link to the triangle as well. And those are free to use and free to copy. Excuse me. And if you're interested in learning more about coding with Python and Turtle, I recommend that you start off with this and use some of the tutorials that are there. So today we just wanted to kind of show the PREM method, but also give you something that you can work with. So here's the last question for today. given the strategies that I shared with you, we talked about pair programming, use, modify, create, and prim. Of those, which one are you most likely to try with your own students in the classroom? If you joined late and you didn't get the link to the WooClap, Eva, if you could just throw that back up into the chat so anyone who is now live with us can answer the question. Looks like we've got some people saying that they would use the use, modify, create, which I think actually is probably the easiest one to jump into. You know, if I was teaching in the classroom right now and had to start off with a young group of students, I would definitely use the use, modify, create. But I would also use pair programming together, and you can use pair programming together with prim or use, modify, create. It doesn't necessarily have to be a separate pedagogical approach by itself. It can be combined. Awesome. And so we've got a few people who are saying that they're willing to try all of the strategies. We got the go-getters in the group. Awesome. So thank you all for taking part in the questionnaire, but I'm going to turn it back over to Eva to share some more information about BSD and some other opportunities that you can have to interact with us in our content.
All right. Thank you so much, Mark. So I guess now I can say I do program in Python a little bit. I just need to start practicing.
Yeah.
As always in these webinars, I learn a lot from Mark. So let me just tell you a little bit more about what BSD can offer in the learning experience of bringing code into their classroom. So for us, what's really important is that we're not only focusing on the hard skills when we're building our curriculum. So this is an example of a project that BSD offers where we bring in the element of with students talking about empathy as well, and how technology is used in their community. So this is an example project where the students learn how to code a multi-page website for a local animal shelter. So there's two ways, many different ways actually. Two main ways though that teachers would like to, and usually the way that they approach the project is to, one, the students can just learn how to code the example website, or another is for students to reach out to their local community and talk to organizations to build a website for these said organizations using the skills that they have learned. So this is an example of a very versatile project where the students bring in many different skills to link it back to technology and how technology plays a role in their world, in their community. So there are three main ways that you can bring BSD into your classroom. Later on, I'll share a link to some of our free projects which you can test out today with your students. They're really easy to use, and just open up the link, choose the project, and you can launch your students right into it. Another way is for teachers yourself to subscribe to a teacher plan for only $12.50 a month for up to 30 students, and you'll have access to our library as well. And another method is, of course, bring BSD in for full certified curriculum of all our 600 hours worth of curriculum into your classroom. And this includes supported PD led by our team, and also coaching, and also live chat support for teaching and learning for students as well. So if you would like to know more about this, you can visit our website as well.
Yeah, I just put the link out there, Eva, for anyone to access that information.
Yeah, so here are some, thank you, Mark. So here are some free, some examples of some of our free projects. And this one's a really fun one, the AI webcam. My favorite website is a great place to start for students. And Trivia Game Maker is also great when wanting to introduce some JavaScript as well. So please take a look at these projects. They're really fun and versatile to do. So feel free to plug in any context as well into these websites and these projects. So finally, I would like to share oh, Mark's already shared it. we really appreciate your feedback and what you think of our webinar series. So please take some time to fill out our feedback form. And meanwhile, we will answer some questions. We have one question from a teacher. So the question is, I think this relates to peer programming. So within online teaching, when we apply peer programming, do BSD have a shared platform for students to practice coding, or they just share screen?
That's a good question, Eva. If you could just, let's just go to sharing our webcams. Yeah, so on our platform, we don't necessarily have like a shared programming environment in which students can share the exact same page of coding, but we have the ability for students to share their own project, and they can copy the link and share it to someone else, and then that student can copy all of the code into their own project. But if I was going to use the pair programming method, I would just have them share the screen and work on that together. But at the end, we do want students to be able to start to customize their own work. So once they completed the assignment, then I would ask the students to make a duplicate of it so that both students have a copy of the project. And one student may go off and modify and change it in one way, and the other student will go off and modify and change it in their own way. So that at the end, students end up having two different results based on their own, kind of customization and what they want it to look like. But along the way in the journey, they'll have completed the steps the same and followed the pair programming method, and which helps with their effective communication skills.
Cool. Another question. Also, are the projects saved in Sandbox transferable to other portfolio platforms?
Yes, yeah, it is. So, we provide the outputs of the HTML, CSS, and JavaScript, which can be embedded into another website, or you can copy and paste that code into any other online editor of your choice.
Awesome. Yeah, BSD Online is pretty great.
Yeah, we've made a pretty dynamic tool that's very useful and has kind of all of these teaching strategies embedded.
Yeah, just a little bit aware of time, but there's two valuable questions here as well. If everyone's okay with it. So Mark, the question is, does BSD offer Python?
That's a good question. We use Python examples today in the webinar, and because it's been such a huge request, we've decided to develop an Introduction to Python course, of which will be available this summer. So if that's something you're interested in, please get in contact with us. It's a 25-hour introductory course. It's suitable for young students as well as older students who've never done Python before.
Awesome. And the final question, it says, I want to teach coding, but I don't know how to myself. Do you have any tips for us?
I think some good tips would be to, first address that fear, right? That's the first step, is that we have a fear of coding. So how do I get over that fear? I think, pair programming is a way to get over that fear. Sit down with someone else who does know how to code, even if it's a little bit, and walk through that process with them and learn with that person. And that will help you to see what you can do and what you can achieve. And then, following any of the methods that we've shared today, which a lot of them involve investigating and tinkering, that helps to give you the confidence that you need so that you can continue to learn and grow your skills. But yeah, you got to acknowledge first that it's a little bit scary.
Yeah, absolutely. Great. So we have a final question, but this one's quite specific to how our portfolio system works. To Na Lee. So I'm going to leave my email here to everybody. If you have any more specific questions in terms of our platform, how that works, and how the portfolio works, please feel free to email me here at ey@bsd.education. And we'll be able to give you a demo of how the platform works and how our portfolio system works and how all of that links together, how the ecosystem comes together with the curriculum. So thank you so much for joining us today. We're 4 minutes behind time. But if you want to watch this all over again or experience it led by a different member of our team, the same topic is covered again in a later webinar in the US in Eastern Standard Time. And also the recording of the session today will be on YouTube. So stay tuned if you want to share this with anyone in your team or anyone in your school. So thank you so much again for your time and have a great day.
Yeah, thanks for hosting, Eva, and hope to see you all next time.
Thank you.
Yep, cheers.
Bye, everyone.